Hi everybody, I'm going to talk through how to do Unit 2, Formative 3. First, I'm going to go through and do all the SEP6 questions, and then I'll go through and do all the SEP5 questions. So for SEP6, I'm going to start by writing down some things that I know and highlighting. So rough carpeted hallway, that's important. The box is moving left. So when I read that, what I like to do is I like to fill in my diagram as I go. So because I know the velocity is to the left because the box is moving left, I just fill that in. Then it's being pushed to the left. So now I'm going to go into my FBD and I'm going to draw a push force to the left. Mr. Erdman's push force is less than the force of friction acting on the box. So I know now I need to maybe make this arrow a little bit tinier since the first force of friction has to be bigger than the push force. So that came from right here. So now I'm going to start to fill in my other forces. There's going to be a force of gravity acting on the box because it's on Earth. There's also going to be a normal force acting on the box because it's on a surface. So for my F net X, those are all the horizontal forces. I always do right minus left for horizontal. So I'm going to do force of friction minus F push. For F net Y, I always do up minus down. It's a D. So I'm going to do Fn minus force of gravity. If I look at my FBD visually, I can tell that the net force is going to be this direction to the right because FF is bigger than F push. And these two always match. They always are the same direction. All right, so now I'm ready to start my explanation. And I'm going to start with something that's important from the prompt. So I'm going to pull something from the prompt that's important as my evidence. And I highlighted a bunch of important things. So what I'm going to write is that it's given that, and I'm going to look at the prompt to ask myself, does the prompt tell me about acceleration? I don't see the word acceleration at all, so I'm not going to start with acceleration. Does the prompt tell me about net force? I'm not going to write that because I don't see the word net force at all in the prompt. Relative forces. I do see some forces. I see push force. I also see force of friction. So I might start here. I also know that the box is moving left. But I'm trying to answer a claim about the velocity. And so this is actually going to go last because that's what I'm trying to answer the claim. So I'm going to start with relevant forces. So it's given that the force of friction is larger, or how does it say it in the prompt? It says the push force is smaller. That's what it says. It says the push force is less than the force of friction. So that's just something directly from the prompt that I'm pulling. And then I need to answer that means. So I've answered relevant forces. What can I make a claim about next? Do I know the velocity? Do I know net force? Do I know acceleration? Well, when I even just looked at my diagram, I knew that the net force is right. And that comes from physics concept number 1, that relevant forces cause a net force. They combine together to make a net force. So now I just repeat what I just said. Given that F net is to the right, So I've answered net force. What can I answer next? Do I know acceleration or do I know velocity? I know acceleration. Acceleration is also to the right because, and you have to include this phrase in your explanation every time, because F net causes acceleration. So now I'm going to try to get to what's happening to speed. So given that accel is to the right, and I'm trying to answer what's happening to the speed, so I need to know the direction of the velocity too. This is physics concept number 3 on page 3 of your packet. And I know velocity is to the left from my diagram, from my notes, but also it says that it's moving left in the prompt. So that means the box will slow down because they're opposite directions. Here, I'll just write this in the next line, but opposite directions. And then I can circle my answer. All right, let's look at the next SEP6 problem. So this time we'll go a little bit, we'll go through it again. So we read the problem. A skydiver jumps out of an airplane. As they fall towards the ground, direction is always important. The skydiver increases speed while the air rushes upwards past them. So this sounds kind of important. There's an air that's rushing past them. I need to draw a motion map, which should include velocity arrows and acceleration arrows. So my velocity arrows are usually the first thing I like to draw because they're a little bit faster. So it's speeding up as it falls downwards, so that means the velocity needs to get bigger or longer. And the acceleration always tells me what the change in velocity is going to be. So to get from the first arrow to the second arrow, I would need to stretch the vector in this direction, downwards. Same thing, to go from the second arrow to the third one, I would need to stretch the arrow longer. And so you can tell that that acceleration is also down. So I'm going to look. I don't need to talk about relevant forces this time, but I do need to talk about net force, velocity, and acceleration. I'm trying to answer a question about net force, so this is going to go last. So that means I'm either going to start with velocity or start with acceleration. If I look at the prompt, what do I know more about? Velocity or acceleration? Speed is not velocity, but it's pretty close. So I'm going to start with talking about speed. So given that, and I'm going to copy something from the prompt, that as they fall down, they increase speed. Okay, so now I need to add some reasoning. So that means, oops. I've talked about velocity, so now I need to talk about acceleration since net force goes last. So that means acceleration is also down. Remember, if velocity and acceleration point the same direction, the object will speed up. So then now I've talked about acceleration. I can get to net force, so that means net force is also down. And then this phrase you need every time, because F net causes acceleration. And I've answered my question. All right, let's go through the next SEP6 question. So again, I'm going to highlight things and add things to my diagram as I hear them. So a forklift is lifting up a box that is 1,700 kilograms. As the box moves upwards, okay, so that means the velocity is up because that's the direction of motion. The lift force on the box is the same as the weight. So when I read weight, anytime I read that, I always just make a little note to myself that that's force of gravity. So now I can look at my FBD. The lift force is the same as the force of gravity. So I'm going to draw tick marks to show that those are the same. Now my F net X, there's no horizontal forces. In vertical, I always do up minus down, so I'll do F lift minus force of gravity. Then looking at my FBD, those two forces are going to balance out, and so I'm going to get a net force of 0. And then acceleration and net force always match, so that means acceleration is also 0. So again, I'm going to look at the question. The question's about velocity, so that means this is going to go last in my order. So that means I must be given either acceleration, net force, or relevant forces in the prompt. And if I read, the one that I know the most about is relevant forces. I know things about the lift force and the force of gravity, the actual forces acting. So I'm going to say, given that the lift force is the same as the force of gravity, then I'm going to try to add some physics reasoning. So what can I tell the reader? Can I tell what the net force is, or can I tell what the acceleration is? Based on physics concept number 1, that forces combine to make a net force, I can draw a conclusion about net force. So that means F net is 0. Because if these forces are totally balanced, the net force has to be 0. So I must go to acceleration next if velocity goes last. So given that F net is equal to 0, that means acceleration is also 0 because net force causes acceleration. So now, given acceleration is 0, and I need to know if the velocity, I know it's not going to be increasing speed or decreasing speed because acceleration is 0, but I need to know, is the velocity moving or is it not moving? Is it moving or is it not moving? And it says that the box moves upwards, so the velocity is upwards. That means it moves at a constant velocity. All right, that is the video for SEP6. There will be another video for SEP5.